会跟我们前方的这个贵宾们靠得这么的近。现场所有的嘉宾们，欢迎您在今天特别拨冗莅临来到我们的化合物半导体的创新应用馆领袖对谈。在这里呢，我们也非常欢迎到我们还有在我们的网络上，在我们的 Semi YouTube 平台上面所一起来观赏的贵宾们。同时呢，我们在今天呢，分别在我们的廊道外方，在我们的1楼 J 区、我们的 I 区以及4楼的 L 区呢，都有大荧幕。如果贵宾们呢，今天也想要在外方来欣赏的话，我们也非常的欢迎，也要再一度的欢迎各位一同的一大早加入到我们今天的领袖对谈。而另外呢，在我们今天呢，在此呢，也要仅代表着我们 Semi 国际半导体产业协会以及 Semi Taiwan 功率暨化合物半导体委员会呢，感谢我们现场所有与会的贵宾，还有我们今天的这个与谈人一同的来到我们的当中。而我们化合物半导体的创新应用馆是由 Semi 规划，以及呢由 Semi Taiwan 功率及化合物半导体委员会所指导的。同时在这里呢，我们也要感谢到许多的赞助厂商，在这里呢，我们要一一的分别要感谢到，就是我们的应用材料、嘉金电子、GaN System、汉明科技、IQE、精城半导体、稳懋。那我们呢在这里哦，能够一起齐聚一堂，也都要感谢他们。所以我邀请我们所有的贵宾们，可以用我们热烈的掌声，先来谢谢我们所有的赞助厂商。真的，我们很难得，在我们今天的这个年底哦，可以这么多人齐聚一堂，然后一起来分享到我们科技还有产业最新的新知。So first of all, good morning, everyone. And people who is watching our YouTube, welcome to the Compound Semiconductor Innovation Zone, the Semi Talks. On behalf of the Semi and Semi Taiwan Power and Compound Semiconductor Committee, we would like to thank you all of you joining and our distinguished guests who joined the Compound Semiconductor Innovation Zone. For this year and for this zone, we organized by the Semi and it is hosted by the Semi Taiwan Power and Compound Semiconductor Committee. And it is sponsored by the Applied Material, Epicel, GaN System, Hermes Epitech, IQE, Unicorn, and Wing. So once again, we'd like to thank you for all our sponsors for letting us to gather around and sitting here to have all these technologies. 那紧接下来，在我们今天整个活动的一开始啊，当然我们也要先邀请到就是我们 Semi Taiwan 的功率暨化合物半导体委员会主席，同时呢，也是我们稳懋半导体的策略长李宗恒先生来到我们当中，为我们来进行致辞。So without further ado, I shall now welcome the chairman of Semi Taiwan Power and the Compound Semiconductor Committee and the CEO of Wing, please.
各位嘉宾、各位专家学者，大家好。
好。
真的蛮高兴说停办了1年的 Semicon， 然后今年又开始举办了。那大家都知道，如果在 communication 部分呢聚在一起，大家能够面对面的对谈是最有效率的。那蛮高兴今年呢，在疫情能够稳定的控制之下呢，大家能够齐聚一堂。那在这个化合物半导体这个产业里面呢，大家都知道。整个的产业是在起飞，这才是一个开始而已。那不管在电动车的应用也好，这个 RF 应用也好，手机应用也好，人脸辨识也好，还有一些 power device 也好，我想都在渐渐的起飞一样一样的 technology， 一样一样的 application， 陆陆续续都在这个进展当中。那这个技术呢就非常重要，要让 application 能够发光发热，就必须要有技术先行。那我想在我们这个创新应用馆呢，就是介绍给各位呢未来的一些趋势，还有我们现在的这个技术的一个走向。那我想这个应用馆是非常对大家非常有用的让大家能够多多的交流，也知道说未来的一个市场上的一个趋势。那这样才知道说你投入的资源还有这个整个未来的应用，你知道你走对了一个方向。那另外是说大家能够合作，我想大家也知道，半导体一直在等于说各个国家大家都在发展，每个国家都自己在发展。那我想化合物半导体也是一样。那我希望大家能够一起合作，然后把它开创这个市场，让市场继续做大。那在化合物半导体我们的 committee 里面呢包括成员都从上游到下游 ，design house、foundry、material、equipment。的 packaging 全部都包在里面，也希望呢有兴趣的能够加入我们。那我想今天呢， 希望大家能够 enjoy 今天的这个秀哈。我想我们邀请非常多的专家学者来这个介绍给大家未来的一个趋势跟技术。好，希望大家能够enjoy 这个秀。谢谢各位。
谢谢 ，Thank you Chairman Lee， 相当感谢主席所带来的这个开场致辞，也揭开了我们今天稍后的领袖对谈的序幕。那接下来我们就要展开到我们今天为各位带来精彩的 Semi Talk 领袖对谈。Without further ado, we're now head into the Semi Talks. The panel will talk about the Taiwan's competition edge in the wide bandgap compliant semiconductor. 那接下来呢，我们就要欢迎到我们今天的这个对谈的主持人，先来加入到我们的行列。首先呢，我们就要欢迎到我们 Semi Taiwan 功率及化合物半导体委员会的副主席及联影光电技术长林家福博士来到我们的当中。So first of all, let us welcome our moderator, Dr. Barry Lin, the Vice Chairman of Semi Taiwan Power and Compound Semiconductor Committee and the CTO of WaveTech. 我们欢迎博士。那接下来呢，也要为各位邀请到，也就是我们今天的4位语坛人一起来到我们的当中了。And next on, I'm going to welcome the 4 panelists to come up and join us. 首先呢，我们要邀请到的就是联华电子的郑子明协理 ，the Dr. Osbert Chan, the Associate Vice President of UMC. Welcome， 欢迎郑协理。And also, we would like to welcome Mr. Stephen Coates, the General Manager of Asia of GaN System. I would like to invite Stephen to come up and join us. Welcome, Stephen. 继续呢，我们要邀请到的就是汉磊科技的张载良行销业务中心副总经理。We would like to welcome Mr. Lance Dam, VP of Sales and Marketing from Epicel Technologies. 再来，我们要邀请到是台湾大学电机工程学系的陈耀明教授及副系主任 ，Professor Yao Ming Chen from National Taiwan University. 继续呢，我们也要邀请我们所有的好朋友们，用热烈的掌声来欢迎到我们现在在舞台上面几位，以及把我们的麦克风交给到我们今天的主持人。我们以热烈的掌声再一度欢迎他们。
So good morning, everyone. Especially, I see so many friends standing outside. Apologize for that, but I think today's meeting will worth you standing there. Okay, so hang on with us. All right. So today, we actually want to focus one of the key technologies in the compound semiconductor area. In the past several years, we continuously to introduce a compound semiconductor in this forum and turned out to be very successful. So we have been focused on the 5G communication using the gallium arsenide. We have been focusing on the VCSEL using the gallium arsenide as well as the indium phosphide technologies. But today, we're so-called, we call it the wide bandgap material technologies. I think that will be one of the most exciting technology to be introduced to the world. And that information actually is shared this year in yours report. As you can see, in the past several years, starting from 2018, you can see worldwide, a lot of companies come into the pictures, including the design house, the application side, from the foundry, from the material, as well as most exciting is that a lot of system house join this wagon. And I think this bring out a lot of excitement in the industry. And so, as you can see, Taiwan is in part of this hub. And I will say today we'll address what will be our competition edge, what will bring us to the pictures. So as you can see, that is gallium nitride technology. But the next one I will show you, and also is in the wide bandgap material, is a silicon carbide area. Again, in the US report this year, you will see separated out by different technologies, separation, segregation. You will see worldwide a lot of companies join this bandwagon. All right, and Taiwan is not missing. You can see today we have a representative from Taiwan industry talk about application, talk about the foundry technology, talk about the fabless design. Definitely, we also have a representative from other sector like material, epi growth, but not in the not in the panel, but maybe they are in the audience. So today we'll welcome your question, and the panelists, or I would say the expert in this area. So welcome your very tough question. Okay, don't be shy. Just raise your hand. So next one. This I borrowed one of the slide from Dr. Wu Ziyi. He's ISRI's Earth's directors. So he lists out all the compound semiconductor industry in Taiwan. So today, so separate by GaN as well as silicon carbide. So you see, we have a lot of participants in this area, starting from application. This is the substrate and the epi texture, the epi house, and the foundry, and the chip design. In the assembly, actually, it didn't list out. You will see, we have a lot of assembly house today. I just talked to Tongshin as well. They actually is a lot of part of this group already. Okay, so we'll welcome all this audience to join in this discussion. But in order to focus today's topic, so I just proposed 4 different questions, and we'll ask our panelists to give their viewpoint for several minutes, and then we can open question to the floor, and we'll ask your questions and also answer it. So the first question we'd like to address is that we think that both silicon carbide and the gallium nitride have their own comfortable application zone. But there definitely are some overlap area, and maybe we can talk about how we can make this differentiation much more acceptable to the industry. The purpose is that we don't want to bring out the differences. We want to make both technology to very prosperous in Taiwan. Okay, so the overlap area definitely there's some competition, but this competition, I would say, is very healthy, and also could be a very complementary. All right. The second question we'd like to ask is that what is Taiwan's competition edge in the foundry services? As you can see, we have a lot of company in the silicon foundry area, very successful in the past, including TSMC, UMC, Vanguard, blah, blah, blah. But what will be the very, very key successful foundry services for us in the future, especially in competition with the Western or Chinese foundries? What will be our competition edge? So we can all talk about this today. The third question I'd like to ask is that, what will be the fabless house competition edge? Definitely in the silicon area, we bring out a lot of fabless house development in the past. And what those houses should be play roles in this future wide bandgap material. Okay, so we talk about foundry technology. We talk about the fabless competition, but definitely we haven't talked about assembly as well as testing in this talk. But you can ask all those questions. Okay, I can list out all the questions for you, But welcome your questions, all right? We should have a lot of expert in the audience. The last one I'd like to ask everyone is that, what would be Taiwan's countermeasure to face all this big investment in the foreign country, such as in the US, such as in China? Those all invest billion dollars into this wide bandgap material. What will be Taiwan's position, countermeasure to face that? Okay, so you can think about that. But before you raise your question, I'd like to introduce every panelist one by one. So they will give you about 3 to 5 minutes introduction talk to bring out their points. And then, the purpose of that is that to really lead you to think about the question and what you would like to ask, all right? So the first one I'd like to introduce to you is Mr. Stephen Coates. Mr. Stephen Coates. I think the MC will, so MC will introduce, right? All right, sorry. Maybe let me introduce Stephen Coates. Hi, Stephen. Yeah, welcome.
Thanks, Barry.
Yeah, I think Stephen is quite very popular in Taiwan, especially to promote this gallium nitride technologies. So this morning, I just joked with him, hey, Stephen, I think you've become a part of the Taiwanese now. So welcome, especially he told me that he just got a ARPC, right?
APRC.
APRC, yeah. It's basically, he's part of Taiwanese now. All right, welcome, Stephen.
Thank you. Can I get the... Okay. So what I'd like to do, I'd like to start and just talk a little bit about the applications and focusing really on the electric vehicle. So I thought that it would be interesting for the audience to just learn a little bit more about how compound, GaN, and silicon carbide are both really now starting to make tremendous inroads in the electric vehicle world. So many applications in the car. I think some of these applications are well known. The onboard charger, the DC to DC converter, the traction inverter. Maybe less so, things like the LiDAR sensors, things like wireless phone charging in the cabin. Audio, Class D audio is really now starting to come to the forefront. And we see that there's $400 worth of power content per vehicle. So this is a tremendous market opportunity. If we convert that into 55 million EVs over the next 20 years, that's an additional 22 billion market opportunity. And that, I think, is something that here in Taiwan, I think we really want to be taking full advantage of. So I'll talk generally here. You can see, I think, that GaN and silicon carbide both outperform silicon. Very interesting is a comment, one of our customers, GaN everywhere they can, silicon carbide only where they have to. But I think the key point here is that compound in GaN and silicon carbide both very much outweigh the performance of silicon. And reliability is also something that's really important. And I think this is an area that, again, I think here in Taiwan, we can really start to be at the forefront, thinking about the reliability requirements for the electric vehicle. it's very important, I think, to be able to demonstrate silicon-type reliability for a compound device. So many applications beyond the electric vehicle. Chargers, fast chargers. We have devices in space, and again, you know, I think this is also an area that high reliability is something, again, that I think is very important for compound. So with that, I'll happily take questions now, or I can pass to Osbert.
Maybe you hold up your question. So let the audience think first. And then we'll go through all the panelists. And then after that, we open to the floor.
Okay.
All right? Okay.
Very good.
So next one, sorry. I was expecting your slide to introduce your background, but technical problem, okay? So they just told me it's not there. So just make it up. Stephen Coate, he's a GaN System General Manager in Asia. All right, so welcome. So next one, I'd like to introduce is Dr. Osbert Chen, and he's currently the Associate VP in the EMC Group, and he's responsible for the technology development, especially not just in silicon area, also in compound area, especially in the wide bandgap material. So let's welcome Osbert.
Hi, thanks, Barry. I'm Osbert from UMC. Today, I'm trying to touch about what's the Taiwan's competition edge from the wide bandgap material point of view. We think that for the wide bandgap material, it's a fast-growing market that worth us to address. With although the existing volume is not so huge as compared to silicon, but we think the double-digit CAGR is really worth us to focus on. And earlier, Stephen have introduced us about the power application. In addition to the power application, we think for the RF application, it's also important, especially for GaN on silicon or GaN on carbide. From Taiwan's point of view, what's the competition edge? I think that the most important is the ecosystem that we already established, especially on the silicon field, especially during the 2 years. You know that Taiwan's foundry really play a more important role. So we think that based on the existing ecosystem, we definitely have the foundation to migrate to a new material, especially on the wide bandgap, either gallium nitride or silicon carbide. On the other hand, how Taiwan can migrate into the new material? For the gallium nitride, we think that there are two approaches. One is the gallium nitride on silicon base. The other one is the gallium nitride on silicon carbide. Both of the technology have its uniqueness. But from our company point of view, because we are well established on the silicon technology, so it's more easy or lower barrier for us to migrate first from GaN on silicon. And then we try to think about the GaN on carbide. For the compound technology, there is a very different technology as compared to silicon. It's the back-end of line process. For silicon, we usually use aluminum or copper. But for the compound technology, gold and aluminum, back-end of line process is set as a default for RF and power respectively. So how to manage the back-end of line with different material without cross-contamination will definitely be a key to challenge to our fab process. And based on UMC's experience and our cooperate with WebTech, we think that this kind of different back-end material handling should be okay and can be under handling within one fab. The other one is that the talent. I think talent is most unique from Taiwan. During the past 10 years or 20 years, we know that the science park have a very close correlation with the academy, especially from Hsinchu Science Park and the Thailand Science Park. At this moment, we got fully support from the talent from the academy to industry. The channel is very, very smoothly. So I think that in the future, for the compound, the talent still play a very, very important role. And the existing ecosystem between the academy and the industry should pass a very good foundation for Taiwan to migrate into the wide bandgap material. The final point is that we think foundry is not a pure technology, but a service. So how the company can get a good foundry technology, the most important is the company culture. During the past 10 years, Taiwan have set a very good foundation, especially in the foundry. No matter it's the leading silicon foundry or leading compound foundry, this kind of special culture, I think, is Taiwan's uniqueness. And definitely, even from China or Western company, they cannot catch within 3 to 5 years. Such kind of a good culture, I think, should be a very, very good foundation for us, especially for Taiwan, to still leading the worldwide foundry technology, especially in compound. Thanks.
All right, so thanks, Oscar. Next one, I'd like to call Mr. Lance Teo. He is currently the Vice President from Epicel.
I have a dream. My name is Lance. I'm in charge of sales marketing for Epicel, a pure play foundry service for power device, including GaN and silicon carbide. So my dream is to have the wide bandgap fabless designer to have your design becoming a true physical product. This is to make your dream come true. Okay. So today you may know that most of the silicon carbide is coming from the IDM. Okay. So how could have a fabless designer of silicon carbide to have your design realized? The only path is to go through foundry. Okay, so today I would like to share with you what is the key feature to have a perfect pure foundry. Okay, so this is my major talking points. How could be the key feature to be professional wide bandgap foundry? First of all, you need to be a pure play foundry. You know that you don't want to have your design becoming a part of your foundry service, or become, or you would like to have your capacity conflict with the mother foundry. So you have to engage with a pure play foundry. So this is the first. And the second thing, that you need to have a foundry to have a decades of engineering development and years of manufacturing, okay? Years of mass production experience. And then you need to have a complete technology portfolio, from diode to MOSFET, from 600 volt to 3,300 volt. Okay, and one of the very key features of a Taiwanese foundry, you can have a one-stop solution. You know that for supply chains, one of the very important for silicon carbide is about the substrate, the epi service. Okay, then you need to have a foundry who have the one-stop solution. You need to have a very supportive epi supplier. And then as well as you need to have a secure silicon carbide supply from multiple vendors. And then continue to invest in wide bandgap silicon carbide capacity as well as technology development. Okay, this is also very important key feature. And the last one, but not the least, is the You know that right now a lot of people talking about political, geopolitical concern. So this is one of the very major Taiwanese competitive edge. We are in the natural side. We are not in China. Our fab is not in China. Our fab is not in American. We can both serve for all the parties of all the worldwide. Okay. The last 2 pages just make a very quick commercial about Epicure and Epicure Group. We have 2 fab here. Okay, we have 3 fab actually. We have 2 fab engaged for silicon carbide. First of all, is a 4-inch. It has been developed and manufacturing for more than 5 years. So very experienced fab. And the other one is 6B. We have both GaN and silicon carbide. In the coming 3 years, you may have a 5,000 capacity over there per month. Okay? And the last, this is about Epi House is one of the subsidiary. As I mentioned to you, very key feature is to have a reliable supply of Epi. As a professional Epi supplier of precision, they have secured a lot of several multiple of vendor for the substrate. So you don't need to worry about the substrate. This is a very important key feature in the ecosystem of the silicon carbide foundry. It's about the substrate. We have already secured that. And then the last about Epicure, we have, you can read about that. We have several services of that. Okay, from silicon carbide, MOSFET, 6-inch, 4-inch, GaN, as well as some back-end service, including the CP testing. Okay, and for those who would like to have some lift-off service for the foundry, for the front side metallization, we have it. Okay, this is my talk about that. Thank you.
Thank you, Lance. So the next one, I'd like to call Dr. or Professor Chen Yaoming. He's a distinguished professor from National Taiwan University.
Thank you very much, Chairman. It's my honor to be here to share my thought with you. I'm Professor Yaoming Chen from National Taiwan University. My research area is focused on power electronics. Right? The power electronics need a very strong power devices for me to make the switching mode power converters. So actually, we're looking for a very good components that can put into the power converters. And I'm very happy that recently we have the wide bandgap devices available. So we can run a lot of experience. We can make power converter for many different applications. Right? And I just want to share something with you that it may be the common sense, but I want to remind you that electric energy has the advantage in terms of the generation, transmission, and the convergence. This is the most available, most convenient energy that we can have. And electric energy needs to be processed by power converters before it can be used. Like for LED will be different. The motor drive that will be very different. You have to convert DC to AC. Right? And the power switch dominates the conversion efficiency of the power converters. When you're talking about the power convergence, you're always talking about the efficiency. You don't want to lose your energies. So you need a very good switches that can adjust, that can transfer your energy, electric energy in different form, like DC to AC. Right? So ideally, we need an ideal switch that infinity breakdown voltage, no current limits, no turn-on switch or low loss. Okay, very cheap, high reliability. But we all know that those trade-offs among those demanded features. You cannot have everything in one device. So you have to compromise. So I think I would like to provide my opinions on the user end to let the founder know what is the most device that we're looking for, right? And the other things that I would also want to remind everyone that wide bandgap power devices just one part of the power converters. You still need lots of auxiliary circuits to make these power converters work functionally. For example, if we are talking about the high voltage, the silicon carbide can stand for 3,000 volts. But how about the drivers? The driver may be just a silicon IC. So you have to think about that, right? Okay, and that would be my share to everyone. Thank you very much.
Thank you. So next will be our most exciting. We'd like to accept the question from the audience. And think about your question. Yep. Can anyone pass?
Thank you for outstanding presentation. I want to share some of the observation of Taiwan compound semiconductor. I think although we have gallium nitride technology, but currently we only serving the 650 volt and below. And the major sweet spot for the automotive is 1,200 volt. So in that particular application, the substrate need to be revised. Currently, I think the silicon simply cannot accomplish this objective. So that's an area I think we need to evaluate the ceramic substrate, which have a capability to have a thermal expansion coefficient perfect match to gallium nitride. So allow you to grow very thick gallium nitride to accomplish a high voltage application. And secondly, I think for the gallium nitride technology, I think currently, I think all the effort in our location, I think is addressing the lateral device. So we need to have a device structure which can allow to shrink the device size, which means I think from the current lateral device move to a vertical device in a very short time. So allow you to deliver very high current and high frequency. And that's an area I think, like Stephen said, I think that way I think the gallium nitride extend our service area toward the automotive application. And for the silicon carbide technology, I think our major challenge today is our mobility drop. Because although the theoretical, I think the mobility is high, but the actual device today, you measure the mobility is low. So they cannot serve a frequency switch more than 500K. And the ideal situation is the frequency need to be in the megahertz range. But I think for our current device structure, simply I think can only serve 500K and below. So that's one area I think our challenge. Another area for silicon carbide is our current offer is only in a small size of wafer. The leading technology have to move to 8-inch in a very fast pace. And the 8-inch, I think the silicon carbide substrate is a challenge, I think, for all us in here. So I think today, I think those areas, definitely, I think we have a tremendous opportunity. To recap is, for gallium nitride, we simply need to change the substrate from gallium nitride on silicon to gallium nitride on ceramic. And for the silicon carbide, we need to optimize our device so allow you to go to high frequency.
Thank you. I appreciate your valuable opinion. And I think, can you tell your name and also your affiliation so everybody can recognize that?
I'm Thomas Chen. I used to work with Lance. We are from bandgap. But currently, I think working for the material company, Coresium Semiconductor.
Okay, thank you. As you can see, in our panelists, they are equal partner. We have a 50% of a GaN representative, another 50% of silicon carbide representatives. And your question actually also equally divided. So let's let the maybe speaker from the gallium nitride experts talk about his first part of the question. Okay, so you'll go first, and then Stephen.
So I think one of the first questions was really about voltage and the requirement for 800 volt battery. In fact, the majority of EVs that we see under development are actually 400 volt battery, and therefore 650 volt devices are more than suitable for that. We also see that multi-level is one way also to get a higher voltage with a GaN transistor, so some kind of cascaded approach. And I think the prospect of a vertical device obviously is very interesting. We don't feel that is likely in the near term. So I think lateral devices are going to be here for a long time to come. So I think we all, I think, would like to find a solution, if you like, for a vertical device, but I just don't think I don't think it's going to be here in the short term.
From technology point of view, there are two questions. One is the vertical structure. Another is ceramic substrate, such as like a QST, such kind of a substrate. So from a technology point of view, what do you think? Maybe Oscar, do you want to answer that?
Yeah. Okay. I think there are two key questions from you. The first one is how about the substrate? And the other one is how quick we can migrate to 8-inch fab. Indeed, that for higher level voltage application, that definitely will be the silicon carbide application. For GaN, what's the role? I think that GaN is a relatively cheaper, low-cost solution, but in terms of intrinsic behavior, it's not so competitive with silicon carbide. So I think there is a clear segmentation, separation at this moment. 650 volts below, GaN can play a key role. But for above, definitely will be a silicon carbide. And earlier you had mentioned about a key technology is that in terms of intrinsic behavior, GaN mobility should be more higher than the existing one. I think the key is that the material, because right now the GaN is grows on either silicon substrate or carbide. So the lattice mismatch induced degraded quality, especially on the channel, will degrade the mobility. So how to provide a better buffer layer? That's just starting on silicon, maybe on ceramic, or the other choice will definitely help on this one. The other one is the switching speed. For the switching speed, I think it's a trade-off between the breakdown, because there are a lot of field plate design try to redistribute the electric field to guarantee the breakdown capacity. On the other hand, that will definitely lead to heavy load capacitance, so that degrade the capacitance, switching speed. So I think for the material optimization or with the field plate optimization can further enhance the switching speed. The second question is that how the 8-inch fab. I totally agree with your comments that from the market point of view, there is a huge demand to migrate from 6-inch to 8-inch. At this moment, what we see is that they are getting two items. The first one is how the yield can be guaranteed at this moment for 8-inch fab, especially for the epi growth, induced wafer warpage, induced yield degradation should be under control. On the other hand, is at this moment from the market, there is a huge demand on the silicon technology for 8-inch. So it still plays a barrier for Taiwan's company, how willing, how fast we like to migrate from 6-inch to 8-inch, because existing silicon demanding is so huge. So how to leverage the effort, I think is a short-term barrier from industry point of view.
There's still a remaining question for the silicon carbide. Hopefully you still remember the questions. Do I need to repeat that? So maybe Lance, you lead the answer first.
Comment about the ecosystem. I'm not a technical guy. Okay, I think that address on the Thomas questions about the 8-inch silicon carbide availability. I think that right now the one who are really clear to have this roadmap and plan is Wolfspeed. And Wolfspeed, they may have the substrate alone. Everything of the ecosystem is starting from substrate. Okay, this substrate, I think they make the plans in year 2 more years. And then go to AP, go to foundry, everything should be mature probably in 5 years later. Okay, so I believe that FPCL will be definitely a part of them to develop 8-inch in after 5 years. Okay, thank you.
In the technology portion or application portion, can Professor answer that?
I'd like to share some thought in my mind that when you're talking about the power devices from the application end, I agree that high switching frequencies is the one that we are looking for. Okay, you can reduce the size, reduce the heat. Okay, and that's very important. But I also have to note you that when you go to the high frequency, you also have to deal with the EMI. Lots and lots of issues that will come with that. But anyway, the ideal switch with very high switching frequency and very switching loss is the one that we're looking for. Okay, and I'm not a technical guy to make that device, so I can only share my thought from my application end. And I also want to share one thought in my mind that when we're talking about the technology development, you have to think about the human resource. You need a very good person working on that area. You also know that this is not a short-term technology development. You have to have a new blood join your company. You have to train your employee to learn the technology. Yeah. Okay, that will be the share from my end. Thank you.
Do we answer your question? Maybe we can have more, and or after the session, we can have more discussion. But I'd like to invite all others and think about your question. And please raise your hand. Don't be shy. If not, I will ask. Okay. You first. You second. All right. Thank you.
Hello. Hello. Okay. So if we consider speed, as Professor Chen just mentioned, and power density, power handling capability between vertical and lateral structure, is there between these two? Is there any of these two provides advantage over the other for speed, power density, and power handling capability?
Maybe I can take a shot there. I think the big advantage of a vertical device is obviously die size and die area. So there's very significant potential cost advantage depending upon the complexity of the epi and the back end of line. I think in terms of the application, I think what we've found is it's really as much as anything about understanding the customer's requirement to really help the customer deliver the best system level performance. So I think the big advantage of a vertical device really would be the die size and the die area.
So we do have another question from this gentleman.
Yes. My question for silicon carbide. Silicon carbide, from our research point of view, seems will be major application, major material for the power inverter, and also the power charger. Okay, in car, but from the cost structure point of view, compared to foundry industry in silicon, it's totally different. In foundry industry, the wafer costs account for less than 10%, and design foundry probably 50-50. The rest is packaging. Packaging maybe 20%. But in silicon carbide, the substrate costs about 40%. And the AP maybe another 20%. And design cost value is less. And also foundry cost is less. And we have a module as well. So how will I see this industry going forward for the next 10 years? Because we don't have a substrate technology in Taiwan. So that's a key thing, 40% cost in substrate. So what's your view? Thank you.
Yeah, I think that most of the costs, you are right, that half of them is coming from the AP and the substrate. You will talk about 4-inch. It's very difficult because probably it's an old technology, nobody developed really the substrate. So we forget about 4-inch. This cost structure may not be changed at all. Okay, but in the future, it should be 6-inch. And right now, 6-inch is still dominated by several 2 or 3 substrate suppliers. But I believe right now, a lot of suppliers from China, including Taiwan, like Hermes, Taiji, I'm not sure what's the, several players already developed that. And I believe sooner or later they will have it mature, and this cost structure of the of the substrate will be decreased. So I expect at least 20% in the coming years decrease of the cost of the substrate. Okay, so then it's come to 8-inch, but I believe 8-inch is still a long way to go.
The substrate, the production pattern protected.
For sure, there is some IP is already protected, but I believe that because the manufacturing for the very pure content is very difficult. You know that they grow for some, in a day only several centimeter growth of the epi, of the substrate. So this is a very costly and very technical intensive. Thank you.
All right, so we still can accept a question from the audience. Oh, yes.
Okay, good morning. KOA David Ye. I have a general question regarding the semiconductor. In Taiwan, people is most important things. As while we are engaged with wide GaN, especially compound semi, if any the incentive or the progress to encourage all the students, especially university or industry, can join this compound semiconductor industry, not only focus on the TSMC, UMC, or MediaTek.
Hello, this is a $1 million question. I think people talk about this talent, right? Definitely, compound semiconductor need a talent. Yeah, we all recognize very difficult to attract the talent in Taiwan. And I think we do have some opinion, maybe coming from Osper and also from a university point of view. How can you address this question? Taiwan need it. Maybe start with Osper first.
Okay, thank you. I 100% agree with your question. My point of view is that from the silicon technology, at this moment, the technology is driven by most advanced tool, and tool is supported by your CapEx. At this moment, for the academy to study the silicon technology, plastic technology, is nearly impossible. It should be bound with existing large companies like you mentioned, TSMC or UMC. On the other hand, for the compound, what I see is that the dimension, line width is much larger than existing silicon technology. It's still in the quarter micron, sub-micron, not even mentioned to 7 nanometer or 5 nanometer. At this moment, the tool, even though play an important role, but not the determinant role. The determinant is the knowledge, how you can understanding the material, how you understanding the device design. So the talent play a more important role in compound rather than silicon. So I fully agree with you. From industry company point of view, we are more happy, willing to co-work with the academy, with the individual project. And the purpose is not try to get any production technology from academy, but we try to have supported the professor to, with the professor's team, with their student, we can get more and more talent from academy. So back to my talking slide, I think the most important for Taiwan to stand up and keep a leading phase in the semiconductor is talent. And the talent should be supported from industry as a foundation with professors' excellent education. So I fully agree with you.
Thank you for this question. Actually, I was expecting that. And so we have the professor to answer. How will you resolve the talent issue?
Okay, yeah, I'm from National Taiwan University, so I would like to mention that every student have their talent. Okay, you cannot just ask one talent from every individual student. All right, just like you cannot ask a very excellent swimmer to run very fast. All right, that's the same philosophy. All right. So if you are looking for a student, want to attract them to join your company, to join this industry, you have to show them their vision. You have to let them know that, wow, working on this may be not the best in other people's view, but this could be the best choice for your career, right? Not to mention that there are many students want to go to TSMC or any other semiconductor company. You also need to know that there are lots of students that want to study on software engineering, computer science, because it's very easy. You just sit in the front in the desk and put your hands on the keyboard. You can run lots of things, right? And also there are lots of big area in security, network security. Okay, so if you want to attract more students and go to your company or go to this area, you have to create the opportunity. You have to create a chance. One of the chance would be cooperate with university, working on a small project, and let the student know what is the actually the career in your company or in this field. You show them the vision, and they, not everyone will take that, but maybe 10% or 20% will take that. And you got the sufficient number of students that can join you. And remember, students, they will be affected by their peers. Okay, when a group of students come to your lab or come to this field, and they will attract more students, more people to join this industry. And I think we need a association or consortium like a Semicon to do this, to encourage the student to try to understand the study in this field, try to understand the future of this industry. Yeah, and that's my viewpoint. Thank you.
Good. Hopefully, such kind of a forum, we can continue to grow and attract the audience and also the interest from the youngest.
Hi, good morning. I'm a professor from National Taiwan University. I have been working on the silicon carbide for more than 20 years. Now I just start up a new silicon carbide company, 碳系电子. The English name is CKF. For the students, I think I have co-worked with the APC for many, many years. But you can ask him there, is there any National Taiwan student working there? I'm not sure, but mostly the students in Taiwan now, they are looking for the TSMC because of the salary. Even we have the vision for them, but also they wanted to do the compound semiconductor, but they will have some stress from family, from the society. People will ask, where do you work? If students say, I work in a small company, maybe he got a lot of stress. But if he said, I work in TSMC, then the people around him will think he is very good. So that's the big difference. So I think we should do more effort on compound semiconductor. Let most students know compound semiconductor will be the key point in the future, not just TSMC. Especially now on TV, people always talk about TSMC in Tainan, in Kaohsiung, in Hsinchu, even in Japan, in United States. Does anyone talking about a compound semiconductor? Only on business. In education, nobody talk about a compound semiconductor. So that's my point.
Thank you, thank you. I think we do have a voice from the academia, and that's very important. In order to make this technology continue to grow, the cooperation between the academia and the industry is eminent. Okay, we should do that. But you point out one good thing in Taiwan, how we promote this into the youngest. That's very important. And I think that's why the SEMI continue to really do this wonderful promotion to the audience, especially to educate the newcomers into this industry. And I do appreciate you both, your voice from the university. And from industry point of view, we do need the people to study, to get the knowledge and come to the industry to help growth of these technologies, okay? And I see we still have one more question. How many minutes do we have? Oh, time's up. Sorry, I missed the time. I didn't see the 5 minutes. I told them, give me 5 minutes so I can accept the very last question, okay? But anyway.
We can have one last question.
One last question. Good, good. Hold on. Is any, okay, any other? If not, we'll give the choice to, well, sorry.
I just want to have a comment on regarding to the question we just discussed, how to attract talents. And I think when we're talking about the talent, we should always consider globally. I think today, I think we as a very, very highly competition in attracting talent in semiconductor here. I think the compound semiconductor, a lot of them are material science, not electrical engineering. So a good material science school is, I think globally you can find a lot of them. So when we are addressing the talent, I think we should always considered a global talent.
That's a good point. That's a good point. I think even the government noticed that, and to open up the international talent into the Taiwan industry almost will become possible in the future. That's what I heard. Okay, so I think it's time for me to make a very final closing remark. Hopefully, this closing remarks will bring you the hope, will bring you the interest, bring you the excitement to this compound semiconductor. I think in the past several decades, Taiwan is very excel in this semiconductor industry. So we do have that DNA. Everyone carry that DNA. Even you ask the people, what's a TMC, what's a UMC? People recognize, yes, that's a dollar sign. Okay? But they didn't recognize that's the technology behind that. Important. So I would like to say, let's make the compound semiconductor to the next excellent technology in Taiwan in the future. Because everyone in your blood, you have that IC DNA. You recognize the Taiwan's mentality. You recognize the Taiwan's importance, and this technology grows. Okay? So I heard the voice. Your voice is well received. We need a talent. We need a university to cooperate with the industry in the future. We have the industrial representative from the panelists. They all heard that. So I hope that with this kind of a continual promotion, let's make Taiwan be aware of this, not just from governmental level, also from the the grassroots level. All right. And today I didn't mention one very important technology. We also can be very important in the future. Is our assembly packaging technology, like Tongshin. Okay, I just recognize maybe 30, 40 years ago, we sort of worked together for the first generation eye packaging. Okay, very important. Taiwan has that kind of technology. You never recognize that. That will make the compound semiconductor become our next generation. We 常常讲叫护国神山. Okay, so I don't know how to translate in English because I never heard that in the U.S. Okay, but in Taiwan it's very popular. It's very popular. So let's recognize that and make it happen. Okay, so I have that. Well, I said my personal mission. I've been working for compound semiconductor for my life. All right, I think that in the audience, maybe you have a more your career timeline in other technology, but my career is in compound semiconductor. All right, so I have that mission, and I have that excitement to make it happen. Okay, so with all this, we thank Semicon, especially the Semi, continues to support, to promote this technology to Taiwan, and with all this people in the audience, I can see Taiwan had that future. That all pray for it. That's hope it. Thank you for your coming.
Thank you, Doctor, and thank you for all our panelists. And I would like to invite for all of you to remain in the front, and let's take a picture together. 那我现在要邀请到我们的这个贵宾一起来看相，来一起合影。Shall we stand up? Okay, I would like to invite all of you to stand up and stand closer. We have two. We're going to have two photo codes, and one is Doctor and all our panelists. And let's look into the front with your cheerful smile. Okay, and one more. I would like to invite. What was your thumbs up, please? And I would like to invite our chairman Lee, Brian, and also we would like to have Dr. Chen Yichen, 也就是我们的副主席，一起来到我们的当中，同时中山大学的所长。And may we take off our mask for one picture, please? Okay. All right, with your cheerful smile, please. Look into the front. And one more with the thumbs up. Okay, thank you everyone. Once again, round applause. 我们再一次热烈的掌声，谢谢我们今天上午议程所带来的这个精彩的对谈。而紧接下来呢，我要邀请所有有参加到 Power in Compound Networking Launch On 的贵宾，受邀参加 Power in Compound Networking Launch On 的贵宾，跟着我们的 Follow Me。在各位左手边，我们 Follow Me 手举牌的工作人员移驾来用餐。And I would like to invite who have joined the Power in Compound Networking Launch-On. Please follow our staff who is holding the Follow Me badge. Please follow the Follow Me badge to the Power in Compound Networking Launch-On for your lunch. 邀请到所有有参与到 Power in Compound Networking 的贵宾。来，一起跟随着我们 Follow Me 手举牌的工作人员移驾用餐。那接下来我们在今天下午的议程将会于2点开始，2点开始，邀请贵宾们也千万不要错过了。For our afternoon session, we will start at 2, and I would like to invite all of you to come back and join us, and see you soon. 再次谢谢我们现场所有与会嘉宾们参与到我们今天上午精彩的领袖对谈。Once again, thank you everyone for joining the Semi Talks.